Welcome to all. Myself Dr. Diptiranjan Patnaik, and I am working as assistant professor in GL Bajaj Institute of Technology and Management, Greater Noida. This is the our today's topic is your introduction to error correction and detection. First of all, what is error? Okay. So, whenever we deal with data communication, then one of the major concern associated with the transmission of the data is the introduction of error. Okay. So, this is the prime factor which degrades the information, information or messages. So, when the digital signal is transmitting through a channel, the signal gets corrupted. Okay. When the digital signal is transmitting through a channel, then the signal gets corrupted. So, let us say this is the digital signal, this is passing through a channel and this is your received signal. Okay. So, why you can see that these are the 0, 0, 0, 0, 0, 0, 1, 0, but at the receiver we can see that these 4 bits are same, we received the same 4 bits, but instead of 0, this fifth one is 0, I am getting 1. This is that 0 is altered or changed to 1. Okay. Now, next 0, 1, 0 is same. So, one bit is just changed due to the addition of noise. This noise can lead to error. Okay. In the binary bits which is transmitted from the transmitter to the receiver. Okay. These errors must be removed. Okay. So, these errors must be removed as the presence of errors changes the actual information content. Why if that 0 is changing to 1, then what will happen? The what is the actual information, it will be changed. Okay. It will change the actual content of the input message. Okay. So, this means 0 is received as 1 or 1 is received as 0, that is nothing but your error. Okay. So, here we already seen that 0 is changing to 1. If this is happening, this is known as your single bit error. Okay. Only single bit is changing, that is single bit error. Similarly, if there is a length of 8 bits, then what is burst error? Burst error is nothing but if there would be 2 or more bits will be changed, then that would be known as burst error. That you can see this 0 is altered to 1, this 0 is altered to 1, 0 is these 4 bits are corrupted and it is changing to 0 to 1, 0 to 1. Okay. So, it is known as burst error. Burst error is nothing but the 2 or more bits in the data unit have changed, but in case of single bit unit, only single bit is changing. So, this puts a question on the accuracy of the digital system. If it is happening, if errors are happening, if 0 will be changed to 1, 1 will be changed to 0, not only single bits, number of bits are transmitting. If number of bits are changing, more number of bits will be changed. How the digital system should be, we can say that it is accurate. This is the big question. Okay. So, therefore, it is necessary to detect the error and correct it. So, in the transmission process, we have to detect the error and we have to also correct these errors. Okay. So, in digital communication, errors occur due to the presence of distortion, noise and interference. Okay. The system reliability, these all are unnecessary phenomenon, okay, which degrades the quality of the signal in the channel. So, the system reliability, okay, the system reliability will be severely affected by these errors. So, in order to improve the reliability of the digital system, we can increase the signal power or decrease the noise power. Okay. So, to improve the reliability of the digital system, we have to increase the signal power and we can decrease the unnecessary noise power. ठीक है, but practically there is a limitation. Okay, practically there is a limitation on the maximum value of the signal to noise ratio. Okay, that is this is the signal to noise ratio. Okay, practically there is a limitation on the maximum value. So what would be the, how this ratio would be maximum? Either we can maximize the S or we can minimize the noise, but we cannot get the highest very high signal to noise ratio every time, because there is a limitation. Okay, there is a limitation on the maximum value of the signal to noise ratio. We cannot increase the ratio beyond the limit. Okay, therefore, for a fixed value of SNR, so how we can approach? See, for a fixed value of SNR, we have to use some kind of coding techniques to improve the quality of the transmitted signal. So we will not focus only on the signal to noise ratio. Instead of signal to noise ratio, we will fix this signal to noise ratio and we will use some kind of coding techniques. Okay, we will use some kind of coding techniques to improve the quality of the transmitted signal. Okay. So what is the note point? Another advantage of using coding is that we can reduce the required value of SNR for a fixed bit error rate. Okay, this will in turn reduce the required transmitted power and the size of the antenna. This is the main advantage of using coding techniques. Okay, to achieve error-free digital communication in the presence of distortion, noise, and interference is the addition of appropriate redundancy to the original data bits. So our target is to achieve the error-free digital communication system. Okay, so error is happening due to distortion, noise, and interference. So we can reduce this error by using some appropriate redundancy to the original data bits. Okay, so that is error control coding is a practical way. Okay, that is nothing but this method is nothing but your error, how to control the error. Okay, so using error control coding is a practical way to achieve a very low bit error rate after transmission over a noisy channel. So you can see that at the sender side we have that is message, then this is generator, then this is message and redundancy bits, then this is your channel, then this is the received information, then what is generator, it will be checker, and after checking it would discard the error and correct or discard the error, and it would be the original message. This is the flow. So the error correcting codes are nothing but the addition of the redundancies. To correct the error, we have to add some redundancy. Okay, that is your unnecessary bits. That redundancies means what? Redundancy means unwanted or unnecessary bits, but these unnecessary bits are most important bits to reduce the error. Okay, to the actual message. So I will add redundancy bits to the actual message bits so that the receiver must properly decode the actual message signal from the encoded one. Okay, there are some techniques are there, we will see in the further classes. These extra bits are called as parity bits. Whatever these extra bits are added, the redundant bits are added in the main message, that is known as parity bits. Okay, these bits allow the detection or sometimes correction of the errors. So these parity bits helps us to correct the bits, or that is to detect or sometimes to correct the errors. The data bits along with the parity bits form a code word. So we can see that data bits plus your parity bits. This is known as your total is known as your code word. Okay. The error control techniques can be divided into two types. One is your error detection technique. Second one is your error correction technique. Okay. First we have to detect the error and then correct these errors. So to detect we are using error detection techniques. To correct these detected errors, we use error correction techniques. These error detecting techniques are capable of only detecting the errors. Okay. So this only error detection techniques only detects the error. Okay. But they cannot correct the errors. But in case of the error correcting techniques, they are capable of detecting as well as correcting the errors. Okay, these are the main basic difference between error detection techniques and error correction techniques. So two basic types of error correcting codes. One is your block codes, second one is your convolutional codes. We already know that encoding enables the addition of coding bits to the data streams done at the transmitter, while decoding is the recovery of the actual data streams from the coded one done at the receiver end. So we see that this is the block code, this is a convolutional codes. So first we will see what is block code, that is linear block code. In block codes, every block of k data digits is encoded into a longer code words of n digits. Okay. So we have k data digits and we will add some other parity bits and total will be your n code length n digits. Okay, that is we can say that code word length will be your n. So this is your message bits k with k bits and this is your parity bits with n minus k bits and total would be your length would be your n. So k is your message bits length, n is your code word length and n minus k is your parity bits length. Okay. Every unique sequence of k data digits fully determines a unique code word of n digits. Okay. In block codes, k data digits are accumulated and then encoded into n digit code words. Okay. At the end of each such block of k message bits, it adds n minus k parity bits. Note, during transmission, the parity bits acts as they are a part of message bits. Okay, during transmission, we are adding message bits and parity bits, and they are playing the role of you can say the part of the message bits. Okay, in the data being transmitted, the leftmost bits of the code word corresponding to the message, and the rightmost bits of the code word corresponds to the parity bits. So this is the one example of basic 4-3 block code. What is 4-3 block code? This is, you can see that this is your okay. So 3 bits are the k. These are 3 bits. 4 is your code word length. Okay, this is your n k. Okay, after adding parity bits. Okay, this would be a even parity or odd parity. So here the assigned parity bits offer even parity. Even parity means the total number of ones would be even number of ones. And okay, this means the total number of ones in the code word after addition will be even. See, this is the number of ones is 0, number of ones is 2, number of ones 2, number of total ones 2, number of total ones 2, here also 2. So all are even. That's why this is known as, this parity bit is also known as even parity bits. Okay. So this represents the block code, representation of the block code nk. This is your n, this is your k. K message bits, okay, the k message bits with m equal this much are parity redundancy bit, this is p of this much. So code word would be your c equal to mp. This is c equal to this much and this much. Error code word is nothing but your E1 to En. So, Ei equal to 1 implies there is a error, Ei equal to 0 implies there is a no error. So, final code word is your received code word plus code word with error. Okay. So, similarly, this is your another block code, that is 5-4 basic block code, okay, Parity code. This could be, you can see that this is the 4 bits data bits k, and this would be 5 data bits n. Okay. N has the length 5 and k has the length 4. If I will add 0, this would be 0. If I will add 1, it would be 0 0 1 1, and you can see that this is also even parity, even number of ones are there. Okay. So, parity checking, what is parity checking? Parity bit means nothing but an additional bit added to the data at the transmitter before transmitting the data. Already read about this. Before adding the parity bit, number of ones or zeros is calculated in the data, okay, to know whether it is even parity or odd parity. Based on this calculation of data, an extra bit is added to the actual information or data. The addition of parity bits to the data will result in the change of data string size. Obviously, if I will add the parity bit to the data bits, then obviously the string size will be changing. Okay. This means if we have an 8-bit data, then after adding a parity bit to the data binary string, it will be become 9 bits. Okay. This is 8 bits, 8-bit data. If I will add one extra bit parity bit, then total length would be 9 bits. Okay. So, this is your binary data string, binary data string. There are two types of parity bits in the error detection. There are even parity, one is odd parity. Okay. So, even parity, if the data has even number of ones, the parity bit is 0. Okay. That is, you see, even number of ones, means parity bit is 0. Okay. If odd number of ones, then it would, parity bit would be 1. For odd parity bits, if the data has odd number of ones, then parity bit is your 0. Okay. So, data is, let us say this is 5 ones, 5 ones means odd number of ones, then parity bit equal to 0, otherwise parity bit equal to 1, because it has 4 even number of ones. Note that the counting of data bits will include the parity bit also. Okay. The counting of data bits will include the parity bits also. Okay. This is the main noting point. The circuit which adds the parity bits to the data transmitter is called parity generator. Okay. The parity bits are transmitted and they are checked at the receiver. If the parity bits sent at the transmitter and the parity bits received at the receiver are not equal, then an error is detected. Okay. Whatever the bits are added, if same added bits are not detected at the receiver side, then it would be treated as error. The circuit which checks the parity bit receiver is called, the circuit which checks the parity at receiver is, this is known as the parity checker. Okay. Sorry. So, you can see the what is even parity and odd parity. We have already seen this. This is 0 0 0. Okay, message bit 0. Parity, if parity bit is 0, this you can see that this is the even parity bits and this is the odd parity bits, because see here number of ones is 0, here 2, number of ones, total number of ones 2, these all are, this is 4. All, that's why this is a even parity. Here you can see the number of ones is 1 1 1 3 1 3 3 3. So, these are odd bits, that is why this is known as odd parity bits. So, what will happen if failure of parity check method? If the number of error introduced in the transmitter code is 2 or any even number, then the parity of received code word will not change. Okay. it will remain even and the receiver will fail to detect the presence of errors. Okay, so let's say 1101 I am sending, I am getting say 1011. Okay, here this is a number of ones is total number of 1 3, that is odd parity. You can see that if I am this 1 is changing to 0, this 0 is changing to 1. After changing also there is a number of bits are 3 only. So this is showing that okay, there is no changing. So even that parity check method is failure here. Okay. Other limitation of parity checker method is that it cannot reveal the position. It cannot reveal the position of the erroneous bits. It you can say that it also cannot correct the error bits either. Okay, these are the limitation of the parity check method. Next, we will see the Shannon's noisy channel coding theorem. This states that for a noisy channel with a capacity C, there exist codes of R less than C with probability of errors this much. With what is EB of R, energy per message bits, R is nothing but your code rate and N is nothing but your number of coded bits. To achieve small probability of error, increase the block code length N while keeping the code rate constant. This is the main idea. To achieve small, if it would be small, that means increase the block code length N. Okay, this should be increased while keeping the code rate constant. That is, code rate is your R should be constant. This requires a large N. This requires large N to reduce P and requires decoders to use large storage and high complexity for large code words of size N. This is the main disadvantage type. Thus, the key problem is the task of searching good error correction codes with large length N to reduce P, as well as decoders that are simple to implement. Okay. So these are the basic we have seen whatever we have seen. So these are the first, what is the error? Okay. Then we put a question on the accuracy of the digital system. Okay. Then how this accuracy can be improved. Okay. Then we see how the bit error rate or the SNR is affecting this to achieve the less error, and how to add some redundancy bits to reduce the error. Then what is parity bits, even parity, odd parity. Okay. Then we have seen that what is the basic types of error correcting codes, that is block codes and convolutional codes. So next, what is the formation of linear block codes? That is nothing but you have to first add that message bit with the parity bit, and then it would be treated as the total code word. Okay. Then we will use the parity bit, adding the parity bit, we can use the parity bits either using odd parity bits technique or even parity bits technique. Okay. Then how the parity is checking, then what is parity checker, parity generator, then information with even and odd parity, what is the failure, why the parity bit is always not correct, that is failure. Then this is the Shannon's noise channel coding theorem, and these are the main books which you can focus this. So thank you very much.